Welcome back, YouTubers. This is Chad Hightower from South Carolina, and today we're going to pick back up on the M38 Go Devil engine that we started several months ago. Some of you are following those videos as far as the engine build goes and kind of know where we've come with that block. It had a major crack in the block, and we did a complete video on how to repair that block, but we're at a point now to where we are beginning to rebuild this thing. So we're going to document the machine processes that take place and the little idiosyncrasies with these little Go Devil engines and why they're built the way they are and why they function the way they function. So today's just going to be a quick overview of kind of what we've got laid out. So the last time we talked, I dropped the crankshaft off at the crankshaft grinder, and it took him, I don't know, 6-7 months to complete the grind. So I picked the crankshaft up last week. So we're going to take a look at that and discuss some issues that the grinder found when it went through the grinding, before it went through the grinding process. So we also have the connecting rods for this engine, and we'll discuss those. I don't know if we'll get to that in that video, but we'll do an inspection on those and how to properly inspect a rod. And then they'll go through the machining process as well. So we'll document that and get them running true the way they should be. So we'll start this video off as the M38 Go Devil engine build, part number 1, NMC. And for those of you who don't know what NMC means, that stands for non-mission capable in the military. So we're going to place this engine into a non-mission capable status. Hopefully by the end of the build we'll be able to change it to a FMC status, which is fully mission capable. So the first thing we're going to discuss is the crankshaft grinder. And when I picked the crankshaft up, he told me that the #1 rod journal was the worst journal on the crankshaft. And sometimes when you run into a situation like that where one journal is not as round as the other, something has happened in the engine that has caused that. Sometimes you can figure it out, sometimes you can't. You just have to just say, well, you know, maybe it's just coincidence. But I have all these books that I collect. Here's the original Army TM, and here's a motor's manual from 1945 to 1954, and I also have a set of Mitchell manuals that I keep here in the shop for these engines. Now, the Mitchell manuals lists everything that the motor's manual and the Army TM lists, but they go an extra step and they list any work orders or issues that the Willis Corporation said was, you know, there's a problem with these engines, let's get it documented. So if the dealerships see any of these issues, they know how to repair it. So I was just checking through the Mitchell's manual, knowing what the crankshaft grinder told me last week, and I found on page 343 in the Mitchell manual where it says work order number 25009. The timing gear oil jet size has been reduced from 70 thousandths to 40 thousandths. This eliminates the oil pressure variation previously occurring at number one connecting rod, which caused this bearing to score or burn. Install a new size oil jet whenever engine front cover is removed or if the number one connecting rod is scored or burned. So we'll keep that in mind when we go through the build on this process, and we'll inspect that oil nozzle and make sure that it is the proper size. There's also another note that sometime during the serial number break when this engine was built, the manufacturers changed the piston head thickness from 3/16 to 1/4 of an inch. When you replace pistons that are heavier than one another, that can also create an imbalance. So eventually we're going to look at those pistons and reweigh those. Now, I've looked at all the connecting rods. 2 of them have the same part number and 2 of them have a later part number. So I know that the engine has been into, and I know that it has been rebuilt, obviously, because the crankshaft is marked. And the data plate on the side of the engine has been marked that it has gone through a rebuild at one time. So with the overview completed, we're going to do a rough tour and just kind of show what we got and what's coming up. So typically when I begin a machine process, I have to think about what needs to be done, and then I have to plan and think about what order of operations do we need to complete first, because if you get some of the steps backwards or out of sequence, it can create more work for you and sometimes can cause bigger issues than that. So I've been kind of thinking about it the last couple of days, and I think we got a plan of what's going to happen. So we're going to do a little walkthrough tour and show you, kind of what we got set up and how we're going to do it. But this engine build is going to take a significant amount of time because of the condition that it was in when it got here. So I'll post some pictures up in the video so you can kind of see. For those of you who haven't been tracking what's going on with this engine. So okay, so we're going to move the camera and set up on the crankshaft and take a good look at it and kind of see, sort of the condition of it, and we'll go from there. So stand by. Okay, so here's our crankshaft for our L134 Go Devil engine. And there's just a couple of things I'd like to point out with these engines, and just, I guess there's a little bit of history involved as well. But these things were mass produced on a tremendous scale in order to provide transportation to the American forces and the British forces through the Land Lease program during World War II. So even though this Jeep was part of the Korean War, I know that this engine was manufactured during the time frame of World War II. So there's a couple of things going on here. So if you look on the throw here, these little offsets opposite of these journals are called throws. And if you'll see a counterbalance right here. And there's one here and one here. There's 4 counterbalances on each rod journal. And those are weights to keep this engine running as smooth as balanced as it can. And they're bolted on. A lot of the older engines, the counterweights are bolted on because they were faster to produce and they were faster to balance. So they would put 4 of these on. And if it didn't balance out, they would either drill the holes out or they would get a different weight of counterbalance and bolt it to the crankshaft and get it within a rough balance before it went into the engine. Now, I'm confident that, these things weren't, precision balanced. they were thrown in the engine just as fast as they can, and you know, let's get it to the boys on the front. And if it lasts a week, it lasts a week. If it lasts a year, then it's, you know, hey, that's even better. So, all right. So the other thing that we want to look at is we want to look at the grinders annotations. And if you look right here, you can see where back in the 60s when this engine was built, the machinist indicated here where the bearings were ground, rods and main bearings were ground to, and they were ground to 20 thousandths under size at that time. So that kind of confirms that this engine has been through a rebuild, and the grinders that ground this crankshaft last week, they have removed, they've stamped out those old numbers and stamped in new numbers on the crankshaft that indicate what the rods and mains have been bored to. So, I mean, ground to. So they were ground at 20 under, and on the second grind, they were ground to 40 under. So, you know, all of our bearing surfaces look good. Obviously, we'll need to measure those and make sure that they are they meet our specification, or meet the TM specifications. So okay, so let's move on to the next order of operations. Okay, so we're here at the engine block, and obviously you can see that I've already got this thing in the block mill, because we're gonna be doing some machining on this deck surface on this engine because of the condition that it's in. So I'm gonna zoom in here and kind of show you why we're doing what we're gonna do. Well, on the last video posted, we did a rough inspection on this block after the pressure test to kind of determine what else needed to be done to get this thing back up to operating speed. And we did a straightness test on the block, and basically I've just got a piece of flat stock that I've ground on the surface grinder, and I know that it's a true flat surface. And the call out in the TM says to, you know, take one of these flatness gauges and stick feeler gauges under the above the deck surface and under the flat to see if you can find, you know, any places in the block that are high or low spots. So we did that, and there is a pretty good high spot right in this area here. And if you can see, I don't even have to stick a feeler gauge under that. I don't know if you can see that or not, but there is a tremendous high spot right in this area, and I've got it marked with machinist ink. So we've got to get that out. We've got to have a perfectly flat surface, and I'm going to estimate that hump is somewhere around 10 thousandths high. So we'll get that machine down hopefully this week. And then on the back side of the block, which you can't see, is that we'll be removing the valve guides out of this engine and installing hardened guides. And I'm still thinking about how we're going to do that. The TM says to hammer them out with a hammer, but you know, this block is one of these engines that, you know, you have to treat it with kid gloves, because if you damage it, they're extremely hard to find. So we may end up doing some heavy machining on the guides to try to get those out.